Right now, a comet that formed somewhere between 10 and 12 billion years ago, nearly 3 times older than our entire solar system, is quietly leaving our cosmic neighborhood forever. And before it disappeared, it left behind a chemical signature that doesn't match anything scientists have ever measured on any comet, anywhere, in the history of studying our galaxy. Not slightly different, not a little unusual, a signal so far outside the normal range that researchers had to publish a paper just to explain how strange it actually is. NASA has confirmed the object is completely natural. But confirming what it isn't and fully explaining what they actually found inside it turned out to be two very different things. I'm your host, and this is Verge. If you're new here, this is exactly the kind of story we live for. The ones where the official explanation and the full explanation aren't quite the same thing. Stay with me, because by the end of this video, you're going to understand exactly what James Webb detected inside this object, why it triggered a genuine debate among scientists that made national headlines, and why the leftover mystery at the center of all of it is still sitting there, unresolved, months after everyone moved on to the next headline. Before we get into it, hit subscribe, because we're just getting started, and there's a lot more of this kind of story coming. Let's start with what this object actually is, because the name alone tells you something important. It's called 3I/ATLAS, and that number 3 in the name isn't random. It means this is only the third object ever confirmed by humanity to have entered our solar system from interstellar space, meaning it didn't form here, orbiting our sun like every planet, moon, and comet we're used to. It formed somewhere else entirely, around a different star in a different part of the galaxy, sometime in the distant past, before eventually getting flung out into the vast emptiness between star systems and drifting for who knows how long until it happened to cross paths with our sun. The first interstellar visitor we ever detected was a strange, elongated object called Oumuamua, spotted in 2017, which came and went so quickly that scientists barely got a good look at it before it was gone. And its unusual shape and behavior actually sparked real scientific speculation at the time about whether it could be artificial. The second was a comet called Borisov, discovered in 2019, which behaved much more like a normal, familiar comet and helped calm some of that speculation down. Then, on July 1st of 2025, a NASA-funded survey telescope in Chile, part of a network called ATLAS, which exists specifically to scan the skies for exactly this kind of object, picked up a fast-moving point of light on a trajectory that immediately stood out. It was moving too fast, on too extreme a path, to be gravitationally bound to our sun. This was visitor number 3. 3I/ATLAS made its closest approach to the sun on October 29, 2025. And unlike its predecessors, this one turned out to be a serious scientific opportunity, because astronomers caught it early enough, and it was active enough, releasing enough gas and dust as sunlight warmed its surface that nearly every major instrument NASA and its international partners had available got a chance to study it. Hubble captured images. The James Webb Space Telescope turned its incredibly sensitive instruments toward it. Even spacecraft that were never designed to study comets at all, like the Perseverance rover on Mars and the Europa Clipper spacecraft on its way to Jupiter, happened to be positioned well enough to catch glimpses of it as it passed through. This wasn't just an interesting rock drifting through our solar system. It was, for a brief window of time, one of the most closely watched objects in the sky. And here's where the story stops being just an impressive engineering achievement and starts getting genuinely strange. In December of 2025, about 2 months after the comet's closest pass by the sun, scientists using Webb's mid-infrared instrument, called MIRI, captured something that had never been done before for any interstellar object. They got the first detailed mid-infrared chemical fingerprint ever recorded from something that didn't originate in our solar system. And what that fingerprint revealed was a comet releasing methane and carbon dioxide in proportions that didn't match anything researchers had ever measured on a comet before. Not from our own solar system, and not from either of the 2 previous interstellar visitors. Specifically, the ratio of methane to water coming off this comet was measured at roughly 11 times higher than any previously recorded object of its kind. 11 times. Not 11% higher. 11 times higher than the highest ratio ever seen before. Think about what that actually means for a second, because a lot of people hear a statistic like that and it just washes past them. Every comet in our own solar system formed from roughly the same raw material, the same disk of gas and dust that also built our planets, all mixed together under roughly similar conditions of temperature, radiation, and chemistry billions of years ago. That shared origin is exactly why comets in our solar system tend to fall into a fairly predictable range when you measure their chemistry. This object didn't just sit outside that range, it blew past it by more than an order of magnitude. That's the first sign that whatever built this comet did so under conditions completely different from anything that shaped our own cosmic backyard. But that's still not the finding that made scientists genuinely stop and reconsider what they thought they understood. That one came a few months earlier from a completely different team using a completely different instrument, and it involves something even more fundamental than methane. It involves water. A team of researchers, led by a doctoral student named Luis Salazar Manzano, working alongside astronomer Teresa Paneque Carreño, used a powerful array of radio telescopes in Chile called ALMA, specifically built to be sensitive enough to tell apart two nearly identical types of water. Regular water is made of 2 hydrogen atoms and 1 oxygen atom. But there's a heavier version where one of those hydrogen atoms is replaced with a heavier isotope called deuterium, sometimes just called heavy hydrogen. Every object with water in it, whether it's a comet, a planet, or the ocean sitting under the ship that carries you on vacation, has some ratio of regular water to this heavier version, and that ratio acts like a kind of chemical birth certificate. It tells scientists something about the temperature and radiation environment the water formed in long before that object ever became a comet drifting through space. When the team measured that ratio in 3I/ATLAS, the result was almost hard to believe. The amount of heavy water in this comet was roughly 30 times higher than what's typically found in comets from our own solar system, and about 40 times higher than the ratio found in Earth's oceans, 30 and 40 times higher. Researchers involved in the study were direct about what that meant. It was, in their own assessment, the highest ratio of this kind ever measured in any comet or planetary system studied to date, anywhere. Not slightly elevated, the highest ever recorded. Here's the part. Almost nobody explaining this story slows down to actually spell out, and it's the part that should genuinely stop you. Scientists use this exact kind of measurement to reconstruct the environment where an object was born, the same way a forensic scientist might use isotopes in a bone to figure out what someone ate decades earlier. Based on this water signature, researchers concluded that 3I/ATLAS most likely formed in an environment that was significantly colder and had lower levels of radiation than the environment that built our own solar system billions of years ago. And that leads to an uncomfortable, genuinely important scientific conclusion. The conditions that produced our sun, our planets, and eventually us are not automatically the standard recipe for how planetary systems form everywhere else in the galaxy. One of the researchers on the study put it plainly. That might sound obvious when you say it out loud, but proving it with actual physical evidence from an object that formed around a completely different star is something science had never directly done before this comet passed through. So now you have 2 independent, completely separate lines of evidence, one built on methane and carbon dioxide ratios captured by James Webb, and one built on the heavy water signature captured using ALMA, both pointing to the same underlying conclusion from 2 different angles. This object was built somewhere fundamentally different from anywhere we have direct chemical experience with. And here's exactly why NASA and the broader scientific community, while completely confident this is a natural object and not remotely artificial, still can't offer a full, tidy explanation for it. Confirming that a comet is natural just means it's ice, dust, and rock, shaped by ordinary physics and chemistry, rather than built by some kind of technology. It does not mean scientists can immediately explain the exact combination of conditions, the specific mix of cold temperature, low radiation, and formation timeline that would produce chemistry this extreme. Right now, no existing model of how planetary systems form fully accounts for a signature this far outside anything previously measured. The object is natural. The explanation for exactly how nature produced something this unusual is still being worked out piece by piece, using data collected during a visit that will never happen again. There's another detail from this observation campaign worth pausing on, because it shows just how much our estimate of this object actually shifted the more closely we studied it. When 3I/ATLAS was first discovered, early measurements could only offer a rough range for how big its solid nucleus actually was, since most of what telescopes could see early on was the glowing cloud of gas and dust surrounding it, called the coma, rather than the solid object hidden inside. As the comet moved past the sun and began fading afterward, Hubble was able to separate that faint glow of the nucleus from the brighter coma around it, allowing scientists to refine their estimate considerably. The updated figure put the nucleus at roughly 2.5 kilometers across, making it meaningfully larger and likely more massive than Borisov, the second interstellar object we ever confirmed. A larger nucleus meant more surface area, more stored ice, and ultimately more opportunity for instruments like Webb and ALMA to capture a clean, detailed chemical signal instead of a faint, barely measurable trace. That size, combined with how early astronomers caught this object after its discovery in July of 2025, is exactly why this particular comet became such an unusual scientific event. Researchers didn't just get one telescope, one clean data point, and nothing else. They coordinated an entire fleet, and the fact that they did points to something important about how seriously the scientific community treats interstellar visitors the moment one is confirmed. Beyond Hubble and Webb, instruments on NASA's Psyche spacecraft, on its way to study a metal-rich asteroid, captured multiple observations of the comet from tens of millions of miles away, refining its trajectory and studying its coma from an angle no Earth-based telescope could match. Europe's Mars orbiters and NASA's own Mars missions caught glimpses of it as it crossed near the red planet's part of the sky. Even the Parker Solar Probe, normally busy studying our own sun up close, was positioned well enough to contribute data during the comet's closest approach. This wasn't luck. It was the direct result of years of planning, specifically so that if and when another interstellar visitor showed up, humanity wouldn't waste the chance the way we partially did with Oumuamua back in 2017 when it came and went before most of our best instruments could really get a proper look. Because I'm genuinely curious how you'd react to this. If you found out tomorrow that scientists had detected something in deep space that didn't match any known chemical model, before you even knew whether it was natural or artificial, would your first instinct be curiosity, or would your first instinct be concern? Drop that in the comments, because the answer to that question is basically what split the entire scientific and public conversation around this object right down the middle. Because here's where this story gets genuinely strange, and this is the part almost nobody explaining the science side of it wants to sit with for long enough. The unusual methane signature captured by Webb didn't just interest chemists quietly working through a peer-reviewed paper. It became public fuel for a much louder debate. Avi Loeb, a Harvard astrophysicist who leads a research initiative called the Galileo Project, has spent years publicly arguing that unusual interstellar objects deserve serious consideration as potential artificial technology rather than simply being assumed natural by default. When the elevated methane numbers came out, Loeb publicly raised the question of whether the specific gas signature could even hint at some kind of biological process, rather than a purely chemical one, effectively asking out loud whether there was something almost alive buried inside this ancient visitor. The mainstream scientific response to that question was fast, and it was firm. NASA and the overwhelming majority of astronomers studying this object have been clear and consistent. This is a natural comet. The elevated methane is explained through ordinary thermal outgassing, meaning heat and sunlight interacting with ancient ice and releasing trapped gas, a completely natural process, just occurring in an unusually extreme ratio compared to anything measured before. To settle the question even further, researchers with the SETI Institute and the Breakthrough Listen project pointed a large radio telescope array directly at the comet and sifted through close to 74 million individual radio signals detected during their observation window. Every single one of those signals, after careful filtering, was traced back to ordinary human and satellite interference. The study concluded that if any kind of artificial transmitter existed on this object, it would have to be broadcasting at less power than a household light bulb, which is, for all practical purposes, functionally the same as saying there's no credible evidence of any transmitter at all.